Good afternoon, guys, because it's now the afternoon, and I'm trying to hope this one will work. Very quick lesson on sort of comparing standard form, factored form, and vertex form. Now, you've already talked about this quite a bit, probably too much for you, but today I'm going to go over just another little way that we can tie them all together. So, standard form tells us the value in front of the x squared, tells us if it faces up or down, if it's been stretched, and it tells us the y-intercept. Not that great, doesn't give us that much information. Factored form, when we take this and we factor it, this tells us our x-intercepts, r and s, and it tells us again if it's facing up or down and if there's a stretch factor. And vertex form tells us the vertex and up or down and stretch factor. So we started in standard form. And at first, when we first looked at these, I just gave them to you in each form. Now, however, we are able, if we want, to take our equation in standard form and we can factor it and it'll end up in factored form, okay? If it's in factored form and you wanted it to go back to standard form, you would multiply first outside, inside, last, and then multiply the value of a through all of it, and you would end up in standard form. So this one would be to expand. And I remember teaching you that factoring is the opposite of expanding. So this is awesome, except that, as you know, it's not always a factorable expression. So I'm going to put if possible, because it is not always possible. There's two reasons why it's not always possible. Number one, it just might have really nasty intercepts that are on like the square root of 61 kind of deal. Or it may not even have x-intercepts. It may be above the above the x-axis and opening up, or below the x-axis and opening down, in which case it's just not even going to have any intercepts. So this is great when it works. And I'm going to talk about when we would use this over this. Vertex form is wonderful because every single parabola has a vertex. So you can always go from standard form to vertex form, completing the square. Okay, and it's not always pretty, but it's always possible. Okay, then again, if you had it in vertex form and for some reason you wanted to go back to standard form, you would have to write this bracket twice, and again, multiply a through, add your k at the end. So basically, you're going to use the order of operations again, and you could expand back there. Okay. We don't really go from factored form to vertex form and back here. If you wanted to go from factored form to vertex form or this way, you would have to expand and factor or expand and complete the square. So it's a bit of not something that you really want to do. However, I want you to think about this. When do you need to know the intercepts? And let's put this right in the middle, okay? Factored form is going to give you R and let's say S, okay? Oh, see, I did not put S in the right spot. There's S. So R and S are going to give us the intercept. So if you want to know how long a ball was in the air, when does it hit the ground? I'm trying to think of some other ones. The bottom of the arch of a bridge, okay? You're looking for the factored form or the x-intercepts. Vertex form, that's your vertex. That's more when you want to know the maximum or the minimum, okay? And this is going to get really important because we're about to head into some pretty difficult word problems. And you have to know that what form I want to have it in or what information I need depending on what the question's asking me. So what I'm going to do is I'm going to take an equation. Let's see, I'm going to write this one. So I'm going to give it to you in standard form. Y equals negative 3x squared plus 30x minus 27. Now, If I was asking you, or the question was asking you to find the highest point or the lowest point, you would probably go directly into completing the square because you're going to go straight into finding the vertex. If the question has multiple parts, maybe it's asking you something like how long was the ball in the air, which is when we want to know the intercepts, and also when it was at the highest or the lowest, then factoring it does make sense. And this is why. So we'll go over here. First of all, well, actually, we're going to do completing the square because I know this is possible. You know this is possible, and we need to go over this probably. So you divide the 3 out, leaves you with x squared minus 10x, and I've got that minus 27 there. Then, after you've taken that 3 out, you're going to take this x squared minus 10x, you're going to rewrite it, then you're going to get the minus 10, you're going to divide by 2, 5, square it, 25. And you're going to add 25 and subtract 25, like that. Why would I bother to make everything so confusing? Because now I have created this beautiful perfect square. That is going to be x minus 5 squared. So we got an x minus 5 squared. We still have that minus 25 hanging on the end because I haven't used that in my factoring. And then the trick, remember to multiply the negative 3 through. This is where a lot of people forget to do this. They'll put this in here, the 3 in front of the brackets, but they'll forget. Okay? So, we know that this is facing down. It's stretched vertically by 3, and it has a vertex at 5, 48. So that's its maximum, okay? So that's fantastic. It's not going to tell us our x-intercepts at all. It just tells us our vertex. No big deal. This one, why would you want to factor instead of just going straight to complete the square? Well, if I'm asking you for the intercepts, and you are given this one, so if I want the intercepts, I set 0 equal to y, and again, we've got negative 3x squared plus 30x minus 27. So this is our example, okay? And then I had designed this so that it's factorable. I mean, I'm not that silly. X squared minus 10x plus 9. So I divided the negative 3 out of all of them because it's a common factor. I'm going to keep that negative 3 there. I'm left with a simple trinomial. What two numbers multiply to 9 and add to negative 10? X minus 9, x minus 1. Okay, so these are your x-intercepts, and I guess I could go back and I can put this as a y again. So this is your function in factored form. And what does that tell us about this one? We know we have an x-intercept at, well, let's go, it's at 9 and at 1. So if you were to draw this, well, anyhow, so this one tells us our x-intercepts, this one tells us our vertex. You cannot get the x-intercepts from the vertex, but you can get the vertex from the x-intercepts, which we have done in the past, okay? So if we have our x-intercepts at 1 and 9, and I guess I'm going to sketch this down here because I got more room on that side, okay? Here's 1, here's 9, it's facing down, okay? Remember, how do we find the vertex? We find the average of, I'll put this in a different color again. Maybe I'll go with the green. If we know it's at 1 and 9, then we know that 1 plus 9 divided by 2 is 5. If you take this 5 and you substitute it back into your original equation, or even in here, what are you going to find? Well, y equals, I'm going to go with this one. I like the factored form for working with it. 5 minus 9 times 5 minus 1, negative 3 times negative 4 times 4. You get 48. So, from factored form, you can find the vertex. from the vertex, you can't find the factored form. So that's one drawback to having it in vertex form. The good thing about vertex form is that you're always going to be able to put it into vertex form, whereas factoring, you might try and do it and you might hit a dead end because it's not factorable, okay? So I just wanted to go over the reasons why we have learned to factor, why we've learned to complete the square, and the fact is that sometimes if you factor, you can get the information of the vertex form from the factored form by doing a little extra work, okay? And that is much less work than going back and expanding it and completing the square. Okay, all right then, good luck.